How's it going, everyone? Welcome. Eulier Gonzalez here again. Right, so this section is all about the unions and narrowing, right? And I want to make a quick recap of each one of those models and what is the benefits and the takeaway, the key takeaway from each one of those models. So on the first one is to understand where the Typescript came from, which is a project made by Microsoft engineers back in 2011, 2012, when they have a bunch of experience writing static uh, code, aka in C sharp, where you can see the intention of the author since it is explicit about what is the shape of the data at different statements, right? So they have now a problem because all of these applications that are written in JavaScript, and because they now see the internet as this new frontier where they can now sell their assets or to make business on the internet, right? So JavaScript is great for creating prototype, but when it comes to trying to maintain that, especially at corporate scale, it is quite hard to do so. So this bunch of developers uh, at that moment, so they come up with this particularly subset of JavaScript known as the script script shard. I think that's the proper name of that. Let me actually take a look at that. I think it's the script. So script.shard. Exactly, script shard. Right, in April 12, 2011. So, why this tool is, or why that was helpful? Because now when you use now C sharp, you can have is IntelliSense. So the IDE, the integrated development environment, provide you hints about the code. So what are the methods that this specific object is exposed, the properties and methods, and also you can do some refactoring and give you errors at build time, not at runtime. So, uh, and since now this changed how we develop applications at scale, in the traditional sense, we just write JavaScript code in HTML and CSS, and boom, now the browser can understand that. But the browser doesn't understand this subset of JavaScript. Uh, it would provide all of this key advantage stuff, all right? So we can see the author, the intention of the author code. We can know the shape of the data at that particular moment. We can also go with this IntelliSense, which is this it is explicit about how we can. So what are the properties and method that we can go with, right? And the shape of those function call or those properties and detect errors at build time and not at runtime. So, in the case of the TypeScript, we have now this specific development, which is you need to have your own ID, in our case Visual Studio Code, plus a TypeScript server that is going to check, in our case with Visual Studio Code, is any time that we make a file change on a TypeScript files, it will now highlight that error, right? And then if we fix that error, all right, so now it's going to, once that is done, so once we write our programs, so it's going to generate now this JavaScript output ready to be delivered in most or as an evergreen browser, right? So because this particular workflow is now very specific to TypeScript, and also when you're starting to see the most common things that you can get off, which is what this TypeScript server is doing behind the scenes. How can we now set that servers to always listen for a file change in a TypeScript files, and describe what'll be is the output on from the compiler output, as well as some other additional features like on the config files. Okay, so all of this, which is something that I saw here in this chapter, is part of the key aspect, and especially when you're developing now UI interfaces, why it is useful for us to use now this modern front-end development, which is spin up a dev server and and integrate it with our test. So this is now known as Vite. Prior we have things like Webpack, but right now we use now Vite that comes with this TypeScript compiler and some of additional features that are relevant for UI development. So for example, like hot model reload, and when it comes to now make our all of or to make all of our assets ready for the production, by going with a specific model bundler, right, which is different from the development, known as rollup, right? So now we can make sure that all of the work that we did in development now will be reflected and bundle up in a production ready, in a production build, ready to be delivered. Okay, so that's great. That's good, because with all of that, okay, and by understanding its Vite and what Vite is, and why TypeScript config is also somewhat useful, right? And what is VS Code, what is npm, why we use PNP in our case, okay? So as I explore now the TypeScript in the build process, or in other words, is that how now this fits into our web development, right? Is by something that I explained that early, right? It's like, how now TypeScript fits into the web model development, and also how you can compare Vite with TypeScript compiler, how now TypeScript fits into the CI/CD systems, all right, and should you block your dev server or not, and how you can create now a script with TSX, which is convenient if you want to run a database migrations. So for examples, right? So all of these are just a little snippet, or the key key take notes, all right, of these two models, right? And just to make a quick recap is, first thing first is understand where TypeScript comes from, what is the benefit of TypeScript, why we use TypeScript, how you can use TypeScript, and the development workflow with TypeScript, how things were done traditionally, and now how things are done at this moment in 2026 with TypeScript, and how now that TypeScript fits into the web UI development. All right. So in terms of what is the Visual Studio, what is your ID, which is in our case Visual Studio Code, how that also integrate with this model bundler, or this front-end framework known as Vite, how TypeScript fits into that, how TypeScript fits into the CI/CD process, and also why it's important for us to determine if we have to stop the TypeScript server or not. Is this should stop the process or not? And all of this is just to recap about that, right? In some specific snippet, or some specific tool that is in some specific tool that is useful for running some database migrations or some TypeScript script. Okay. So yeah, right. So create a script with TypeScript, and then finally get into the weeds of the basic notations, or essential types and basic notation. So first things first, see how you can do that with functions, and with parameters, how you can pass now the default parameters, or so default in how do you put it? How do you put it? Yeah, default parameters, optional. Yeah, default parameters, optional parameters. How you can define your functions, how you can put now some annotations to that, and what are the annotations we have here in JavaScript, at least to look at the basic TypeScript values, and what are the way of how you can use or how you can describe object typings. Okay, that was quite interesting, I must say. All right, uh, object typing literals, typing value, or object typing literals, typing value literals, right? How we can work with things like map, for example, and what is the shape of that? Uh, why it's useful for us to define all of our typings in a source of truth, and then look at the arrays objects. How you can now specify is the typings of arrays inside of an object, and also in your objects, how you can pass some default parameters, all right, or you can specify, yeah, how you can specify is optional parameters. All right, so arrays in objects in TypeScript, right? So the rest parameter in TypeScript as well for functions. Look at the tuples and how you can define its default values on those, using the optional tuples, as I mentioned. Also look at another basic or essential typing, which is any. All right, and why any can be a footgun in our code for our future, right? And looking also at the function types, typing an event listener with passing a callback, uh, typing a map, typing a set, or the restrictive set types, and typing is JSON parsing, for example, JSON parsing or debugging JSON parsing objects, and typing fetch API response in async function. This is just the basics that at least Matt Pocock put it here and say, this is the I really love about this particular approach, because it actually describes what are the things, the common things in our day-to-day operations. So now that I look at that, right, kickstarted your TypeScript setup and understand how TypeScript fits into the build process, and looking at the essential types and notations, right? So by exploring is the integrated ID environment superpower, so AKA is this tools that the ID enables to go with when we use now TypeScript. So for example is looking at a particular statement, so do some introspection about these statements and variables. That to me was quite mind bending here, right? Understanding also how your how TypeScript fits into your ID. First thing first is this: how TypeScript fits into your ID. Okay, so anytime that you define it, or you write code in TypeScript and you save that, the TypeScript server will runs that, and if there are any errors, it's going to highlight on putting a red line under below the below that section, below that statements, right? And once you fix that, the TypeScript will now runs again, and if there is no error, all right, it removes the red line. So this particular process, which might be silly, okay, to describe, is how now TypeScript fits into your ID, in our case, Visual Studio Code. And then, so what are the features that we can use here? So for example, is this introspection in variables and a statement when we use now TypeScript, which I think that is quite interesting and powerful. Also is exploring this quick fix menu, all right? So not only by hovering on a function call, and how you can now add some comments using the GS doc, for example, and provide some examples of how to use these functions. That's also quite interesting. And when you use this quick fix menu, or triggering is the autocomplete feature, all right? So once you define is the typings, or if those typings already been defined for some other authors. So for example, web APIs like fetch API, the canvas, audio, or HTML forms, you name it, any other API, form data, uh, you know. Uh, so you can look at what are the property and methods that you can go with, which is powerful. And especially when you look at what are the current properties and methods for our value from our basic JavaScript values, right? So for example, strings, numbers, boolean, um, big int, symbols, and well, also the kind of emptiness that doesn't have it. You can explore that, right? So this is the autocomplete features, and now what is the approach of TypeScript to errors? And that is whether it is or there is an error at runtimes, or you are modifying is something that you shouldn't. All right, so you are mutating the shape of the data in an unexpected way, in a way that TypeScript is not aware of. Okay, or it can give you now, especially what is a specific error that can happen. When I realized it was mind bending to me. Or it can be somewhat indirected about the error, and this is something that happens when you use now, for example, some functions, and you try to use or return some unexpected values. But this is like the 4 approaches of TypeScript to errors. So understanding this is quite it's essential as a TypeScript engineer or somebody that work with TypeScript, right? Where the idea is that understand each one of those errors. So in which bucket each one of those errors fill in. Okay, so whether it is or it is a runtime error, or you are modifying something in an unexpected way from TypeScript wise, right? Or you are now it's going to tell you explicitly what to do in that error, or it can be sometimes be quite indirect. That vision is interesting. So then I look at now how this quick fix is helpful for us in terms of how can we remove unused imports, how can we organize our imports alphabetically, which is awesome. How this is helpful for showing off the how do you put it here? Yeah, how this is helpful for showing off is the functions definitions and when this function is being called. Oh my god, this is part of the IntelliSense features, right? Some things that you can do with this quick fix refactoring. All right, so by selecting a target, you can now show off is a quick fix to do some magic stuff here. And by magic I mean is that, hey, I want to put now this computation in the particular function or the local variables and then work with that. Okay. Um, so you can have a reference to. The other is the autocode formatting with prettier. Okay. And sometimes that you need to restart your Typescript server as it is. So in terms of now the narrowing, okay. So here in narrowing, we explore this, and I want to hit the brake here a bit because what the key takeaway of this is that union types and so unions and narrowings. So the essence of union and narrowing is that we can now describe is the different shapes of this, the different I can combine is I can describe. Let me put in my own words. Okay, let me put in my own words. So unions and narrowing. Okay, sir. So unions and narrowings, the key takeaway is that it allows us to, so the unions and narrowing, so unions, okay. So unions and narrowings, allow a system to modify, allow a system to, okay. So unions and narrowings allow our systems to redefine the shape of the data. Okay, why this is important? I do think you can. I think I can be more clear about this. Yeah, I do think I can be more clear about this. Essential type notation is the union and type. So we need to represent different types of we need to represent different type of data in our system, which is why we're looking at narrowing and unions. So in other words, so anytime that you need to represent some, okay. So anytime that you need to represent different shape of data in your system, because your system at the end of the day it evolves. That's why JavaScript is so powerful, right? But also so dangerous for those who don't understand what this system is doing. That's why you need to understand that, right? Especially if you work for any Microsoft products or Netflix, or some any other company out there, right? All of them are heavily reliant on JavaScript. Okay. So, but the point of this is that exactly. So the point of this is so because we need to represent is different shape of we need to represent is different type of data in our system that describe now the new that describe the nature or that describe is the ever-changing nature of the business. That's what I'm gonna do here. Let me write it down here. So because we need to represent the ever-changing nature of the business model in our system, we need to do so. That's why we use narrowing and unions in Typescript. That's the whole point of this, right? Is recognize that despite that these typings are useful to detect some errors at runtimes by throwing errors at build time, but also is recognized the ever-changing nature not only of the system but of the business, okay, of the exchange. That's the reason here, okay, that's the reason here. That actually is what it is, man. So because we need to represent the ever-changing nature of the business model in our systems, that's why we use narrowing and unions in Typescript. All right. So with that, all right, it's like, hey, how do you handle with nulls values in Typescript? Okay. Exactly. How do you handle with null values in Typescript? Diving deeper into union and assignabilities here. Let me go over this.
In this exercise, we have a function called getUsername, and we're passing in getUsername. And what we're doing here is if the username is not equal to null, we return user username. Otherwise, we just return guest. Now down the bottom here, we are expecting to be able to call getUsername either with a string or with null. And this is currently not working. We're getting an error here saying argument of type null is not assignable to parameter of type string. Now, you can imagine, like, we would probably never actually call this with a null value here, but let's imagine it's like a property of a user that we're getting from the database. Well, they might have a name or they might not, depending on how they signed up. So we need to be able to handle nulls here, but currently this declaration of username only handles string. So this sort of check of null is sort of not really doing anything. We need to change this definition, the username definition, to be string or null. Good luck.
Yeah, handling null values in Typescript here. So here it say, hey, I want to pass is a null value. Argument of type null is not assignable to a parameter of string. Okay, so if you for some reason now pass some null value, all right, whether if we say something like this, right, and either we specify as a strings or null as a union type, right? So this is one of the things that when you do this type checking, right, it's actually narrowing down or combining that, particularly here with unions, right? We're just only checking that with unions, and then dive deep into the and then later on dive deep into the narrowing. So far we're looking is at the union. It's like, how do you handle this particular case, right? So if the user exists, all right, so this is what you're gonna do. So but if you want to check what this username will be at this point, right, which is quite interesting, here as you hover here, it say this is a string. Whether is you now check the type of this to be more explicit and say, hey, the type of username, if that is different from object, which is just a nasty thing that is happening there, all right, it's now in a string, but now here is null, you know. So yeah, those are nasty things with that. But in any case, you can see here now is telling that, hey, the username now is null. There is no methods on that null value, all right. So here it won't have anything here. So this is one of the great things, and I get it. Oh my god, and I get it why you are handling null values in Typescript, because from the basic JavaScript values of the of the kind of emptiness value, like null and undefined. So undefined, when you check the type of, is just undefined. So far so good. But when this is now null, the type of this is an object. This is something that goes beyond of today's topics, but this is how you can actually check if the type of if the type of a parameter is a null. All right. And not only that, but that it also, with this narrowing stuff, it tells you when you do that type checking, all right, this is what you want to do. So, right? If you, for example, just indicate this, right? If you say, hey, now this is the username. So behind the scenes, what it's gonna do is say, hey, let me see if this value is a truthy value, or in other words, let me see if this is this is part of the truthy values. From human understanding, it is much easy for us to know what are the falsy values because it's a finite list. All right, so 0, positive 0, negative 0, false, empty string, null, and undefined. All of them are now a falsy value. So if we check here with the engine right now, you say type of this, you say this is now a string, which is good. But the thing is that what is the Boolean value of this, right? And you say this is false, which is good. If you pass now here, this is true. So all the falsy values, whether it's 0 or negative 0 or positive 0, this is go beyond the scope of today's video, or this is null, or this is undefined, right? So if we're receiving now an undefined, a null value, it will detect that as null, right? So here, that's why it's actually say, oh, now the username here, as you can see here, so now the username here is an string, okay? The other kind of, just to wrap this Boolean values here, or the falsy values, whether it's 0, positive 0, or negative 0, or false, or null, or undefined, or an empty string, all of those are evaluated to false in any statement that needs to evaluate that value and converts that into a Boolean. So for example, if statements, or on while loops as well, or do while, right? Okay, so that was quite interesting. Okay, so how you handle now nulls in Typescript, all right? And if you look at the solution here,
okay, in order to do this, we're going to introduce a whole new character that we've not used before and a whole new concept. This is a union type. You create one of these little vertical bars after string, and then this basically operates like an OR character, saying either string or null. So this means then that whatever we pass in here has to be either a string or it has to be null. This OR operator is core to how the OR is core. Nice. Is core to how a lot of TypeScript magic works, really, because we need to be able to represent different possibilities in our system. Because here we can see that getUsername, now getUsername, if we hover over getUsername here, or the username variable inside there, then it's typed as string or null. But magically, once we've checked that it's not null, we can see that if we hover over username inside the template literal there, it's actually typed as string. Fascinating. We will explore the ramifications of this later. But it means, of course, if we hover over getUsername now, we can see that username can either be called with string or it can be called with null, or it can be called with a type that's string or null, which is kind of the thing that we're getting back from our database.
So that was how to handle null types in null values in TypeScript. Okay.
Diving into unions a little bit more, I want to introduce this graph, which was going to come up a lot when we talk about unions and assignability. You can think that, imagine if we have a type like at the top here, where we have string or number there. String or number, it could either receive string or it could receive number. But if you think about it, you can't pass string or number into a function that's just expecting string. So this idea of being able to assign, you can assign string to string or number, you can assign number to string or number, but you can't go the other way around, is really important in TypeScript. And as we work through these exercises, I'm going to expand out this graph with all of the types that belong in TypeScript so we can get a sense for the shape of how TypeScript understands assignability. Very important.
So the whole idea here is that is to understand now how TypeScript handles assignability. Okay, how TypeScript assigns assignability, because it needs to have certainty. It needs to be deterministic. Okay, it makes sense. So how now TypeScript assigns or work with this assignability? Because at the end of the day, it wants to be deterministic about the shape of this data. Okay. You can boil down into that.
In this exercise, we have a move function that takes in a direction, which is typed as string, and a distance, which is typed as number. The idea here is we could move up by 10 pixels or move left by 5 pixels, for instance. But we're actually expecting only a certain set of strings here. We're not expecting you to be able to call it with up, right. Really, the directions that we want are up, left, down, or right. And we want to make sure really that only those are available, and ideally that they would be auto-completable as well. So people using the function could see what types you could pass it. So that's your job, is to try to find a way to type this direction parameter as something that makes sense in this context. You will need to use a literal type, which we've not seen before, and a union type, or rather mash them together and combine them. Good luck.
Okay, this is now looking at restricting functions parameter. Okay, so now that I explore is narrowing with or exploring the null values with the union types and later on the assignability, and why this concept is important in TypeScript as a way to as a way for TypeScript be deterministic about the shape of that data in your system at that point in time. Now it's exploring the restricting parameters here. So this is restricting parameters or literal types, right? Typing literals values. So in our case, I can say, hey, whether if I go and do this and say, hey, whether the value is up or down or left or right, okay, and now abstract all of this by selecting or by highlighting that, and then use the quick fix. Unfortunately, this things doesn't work here. This is interesting. It never works here. Yeah, that's interesting. It never works here. It never works here. It definitely never works here. No code actions available. Hmm. Let me do this. Come on. Hmm. That's right. So what I'm doing is using Cloud Go to help me search for a specific error. Okay. And that specific is not an error. It's just that I should have you should pop up the quick me fix menu for me. Okay. That's what you should do. You should s- show me is this quick fix menu, bro, or girl, or sister. Okay, this might take a while. So while you're doing that, all right, let's move on here to say, well, let's going to select this into a particular target and say, hey, this is the new type called direction. Okay, and for the sake of the typings, you're gonna call this as it is, and you assign this as a value, and this is the possible values that this type can be. All right, so then if you now assign this direction, okay, then when you have access to this direction here, for example like this, and you're trying to or access to that, you are able to explore now is the possible values here, and that is mind bending. You know, this is a mind bending stuff. It's like holy moly, bro. You get the idea here. Okay, it's taking its time. So this is great for this, right? Restricting functions parameter. Awesome, awesome. Okay, okay. So yeah, this is it.
Okay, so the way that we do this is instead of having a string is way too wide for this situation. Instead, we want to do something like this, where we say up or down or left or right, once I finish typing it. Let me zoom out so you can see that. Now we have a type here which is consisted of 4 members of this union type, each of which is the literal string. You can just put literal strings in here. We could put literal numbers in here or literal booleans in here if we wanted as well, but literal strings is what we care about here. So now we have up, down, left and right as the possibilities, and now you could do some logic with up or down or left or right, because we could check if direction equals and we get autocomplete on the options here, which is so nice. We also get autocomplete when we're passing in our arguments, so we can move up, we can move right, we can move down. Oh, it's just so nice. And of course we get errors here by saying argument of type upright is not assignable to this parameter.
This is the idea of looking at the assignability of a value here, right? And this comes to this idea of assign a type to something, right? Unions and assignability.
Is not assignable to this parameter. Very, very cool. Now we can of course just take this and we can extract to a type alias and we can say direction up here. And now this means that our move function, first of all, the errors get a little bit cleaner actually, because instead of having to it sort of spill out all of the union types, we actually just says direction, which is really nice. And instead of having it hover over and it show us, you know, up, down, left or right, we just still get direction there. But of course we still get our beautiful autocomplete. So this is really, really nice. We can capture union types and unions of literals in a type and use it later. And we can also do this, also just have it inline. That's perfectly fine too. It doesn't make too much difference. But this is a really nice introduction to literal types, so literal values in TypeScript, and using them with union types. And oh, this is just fabulous.
Okay. And then literal type assignability here.
Let's look again at our assignability graph here. We now have a bit more complexity. There's now 3 levels where we have this up, down, left, right one in the center here. And this is basically consisting of each of these ones down the bottom. So up, down, left, and right. And finally, those are also assignable to string. You can think of this in the other way around, of course. String is not assignable to up or down or left and right because it's too wide. And each of these, like up or down or left or right, is not assignable to the ones below it either. So you can think of these as kind of, we're getting a sense of like sort of topmost types, like the wider types in TypeScript's ecosystem, and the bottom types, so the ones that are lower in the sort of assignability system.
More.
You can, of course, imagine this too, where if we had a union of, let's say, left or right, then it would be assignable to up or down or left or right, because either of those possibilities can merge into that one. So there we go. This is how literals work in terms of thinking about wideness and narrowness in TypeScript types.
Wideness and narrowness. Okay. Especially on assignabilities and unions, because hey, this type is wide or is narrow. Why this is important again? Because we want to represent is, we want to represent part of we want to represent part of software. Okay. We want to represent part. We want to represent values in our systems. We want to represent value in our we want to represent is values in our systems that reflects the ever-changing nature of the business. So that's why we're looking at the union and narrowing. It makes a lot of sense. So whether if you have or this global or this wide types or this wideness and narrowness concepts, okay, but it's the idea of that anytime that you use now a superset or a subset of a type, this is how you starting to create is this new data that represents a new state of your applications to cover that business use case. Okay.
In this exercise, we have a few different functions here. We have a handle error case function, which takes in a code which is currently typed as string. And then we have a handle success case function, which takes in a code currently typed as string. And we have HTTP code at the top, which is a union of a bunch of different codes, a bunch of 400 codes and 500 codes, and then there's some 200 codes there too. In REST, which is what this is kind of mimicking, 200 codes are considered success cases, and 400 and 500 codes are considered error cases. So what we want to do is we kind of want to split this up into two or a few different types here, because our error case, we want it to handle just the error cases, and our success case, we just want it to handle the success cases. You can see inside the tests, inside the functions, it's expecting code to equal 400s or the 500s, and in the success case, it's expecting code to equal 200s just there. So your job is to try to find a way of changing this type so that we can have maybe several type aliases that all correspond to each one without having too much duplication. Ideally, we don't want sort of multiple of 400 in there because the handle all case is working perfectly well, but it's just the handle error case and handle success case that are currently breaking. So the main little puzzle here is working out how to combine different unions together, and I'll leave that one with you. Good luck.
So if I go to this and I try to get a it's a no code actions. That's interesting. So that command So that's interesting. Like that command doesn't work well there. Okay. Format document. Rename or reference. Go to symbol. Go to reference. Command palette. Hmm. So the TypeScript code activation provider that power desktop VS Code quick fix menu are largely absent. Um, mm-hmm. Mm-hmm. So the idea here is that based on that, so that's what Matt. It's that's what Matt is offering here. It's a not only that you typing here, you do monkey typing, right? Is to understand why you're doing this monkey typing and what is the impact, what is the benefit of doing this, especially to understand is this wideness and narrowness. So if we have all of our HTTP code here, by wrapping all these error cases in a specific type and say error code, right? And all of the success cases into one and say type success code like this. And then if you need to create or to combine or merge or unite two different types, you can do that by combining them and create now a more wide type, a more wide value here, which is success code or error code. You know, it will be is more like N because you actually unite them here, right? That's what you're doing here. So here you say, hey, this is the error code, all right, and this will be now the success code. Okay, so that's the idea in this silly example here. Okay.
So let's figure this out. This HTTP code, we kind of need to split it into a couple of different types. Let's take all of the error types and let's go type error code equals all of these. So now we've got our error code, and this is going to be our success code down here. And now our error case and our success case are going to be pretty easy to type. We can replace this with error code and replace this with success code. But how about our HTTP code down the bottom? We can say type HTTP code. And how should we do this? Well, we can say error code or success code. So this means is just combining those two unions together. So now HTTP code can either, God, I'm having a real trouble saying that. It can either be 400 or 201 or 404 or 204. And this means then that it corresponds to this type down there, which means that, or this type check, which has all the 200 and 400s in it, and it works. So this is a really nice way of thinking about unions that you can later combine them together and make these beautiful combinations.
And to create this Y type here. For specific use cases, right? Okay. Again, that represents the ever-changing nature of the business. Okay. Holy fuck. How big can a union be? That's a very interesting question, but that'll be all for today's video. Take care. Bye bye.